Welcome to the world of fiber optic sensors. This presentation also includes audio explanation wherever necessary. This is intruder pressure sensor based on Fabry-Perot cavity. The Fabry-Perot cavity here is connected to the end of the fiber, is made up of two parallel layers. First layer being a dielectric layer connected to the end of the fiber, and the second layer is a diaphragm. The two layers, which are acting as mirrors, are separated by air gap LS. The incident light here falling on mirror 1 gets partially reflected back due to Fresnel reflection. The remaining light gets transmitted and reflects back by the diaphragm. Due to air gap LS, the two reflected pulses are separated by time 2ls by c, where c is the speed of light. The interferometer connected at the other end detects minimum interference, minimum modulation, and hence the minimum output. In case the intruder presses onto the diaphragm, the air gap reduces to 0 and hence the time gap between the two pulses. The two pulses overlap each other, causing maximum modulation, maximum interference at the interferometer, and hence the maximum output. This triggers the sensor output. Strain or force sensor. Here again, Fabry-Perot cavity is made by two parallel dielectric mirrors separated by air gap LS. This air gap LS varies depending upon strain or force applied externally from the right side. In absence of any strain or force, the air gap LS causes the two reflected pulses to be separated by time 2ls by c. In case the strain or force is applied, the air gap reduces to 0 and hence the two reflected pulses overlap, causing the interferometer to sense maximum interference and hence the maximum output. The position sensor here has one reflection polarizer mirror at an angle 45 degree with the horizontal. When incident light falls on it, single polarized light will be reflected downward into the birefringence wedge in such a way that the refractive index of the wedge remains constant for single polarized light. When input light after reflection from polarizer falls onto the wedge, it refracts away from the plane, reflects upward and again refracts further away from the plane, strikes the reflection polarizer and goes back into the fiber. There will be a spatial gap between the upward and downward pulse. During the position sensing, the transducer shaft is pushed inside, which pushes the wedge towards the left. At the extreme position, the wedge will be completely out of the reflection polarizer. So when input light, when falls on the reflection polarizer, comes downward, it no more enters the wedge and directly reflects upward and back into the fiber in such a way that the spatial gap between the two pulses is zero. In this present condition, when transducer shaft is completely pressed, the interferometer will detect maximum interference, maximum modulation, and hence maximum output.